The least squares assumptions for multiple regressions are, for the most part, the same as the least squares assumptions for one variable regression, except for assumption 4. Let's quickly review what each of these assumptions says. Assumption 1 states that the conditional distribution of the residual U given X has a mean of 0. In plain English, this assumption means that the information left over in the regression residual is not related to the information in the X variable. You can also think of this as saying that the residuals and the X variables are not correlated. We'll focus on talking about this assumption in the next lecture, because upholding this assumption is essential to render unbiased OLS estimators in the multiple regressions. The next assumption says that the distribution of X and Y variables are IID. This assumption is about the sampling process, and the sampling process is not something we worry about in economics and finance because we use observational data instead of experimental data. In observational data, the variables are always assumed to follow an IID distribution. The third assumption says no large outliers in the data, because the presence of large outliers push the estimates of intercept and slope up and down without contributing meaningful information to the estimates. And hence, we have to be very careful about any outliers in the dataset. The fourth assumption is the last assumption is unique to multiple regressions. It says no perfect multilinearity. This is an important assumption empirically and theoretically. We'll spend the rest of the lecture to explain what no perfect multilinearity means. Assuming that all four assumptions hold, then the OLS estimators are unbiased and consistent estimators of the true population betas. Unbiased means that the expected values for the estimated betas are equal to the true population betas. Consistent means that increasing the sample size, the standard errors for the estimators are getting smaller and smaller. Additionally, if the four assumptions hold, we can assume that the OLS estimators in large samples follow a joint normal distribution, which enables us to do hypothesis tests to draw inferences on the betas. Before we move on to the next topic, let's pause this video and do in-class exercise 4.